Hi, I'm Colin Walls, and as usual I'm here to talk about embedded software. Today I want to talk about a feature of the C language, a feature which is widely used and certainly important to embedded developers, but where I actually think the designers could have done a better job, and that is the keyword static. Now, static has essentially three different meanings. And we'll take a quick look at these and then I'll explain why I think it's confusing. First of all, if we take some code like this, we have declared an external variable here called x, it's an integer, and it's outside of all the functions. This variable has a scope which is global. Every function in the application will be able to access x if it wants to. Then we have a function fun, and inside fun we have another variable called y. Y is an automatic. It is stored on the stack and therefore is only alive for as long as the function exists, and has a scope which is just within the function fun. So in this case we have two variables. They're stored in different ways, either in main memory or on the stack, or actually on the stack could be in a register, doesn't matter. And each of them has a defined scope. Now, let's apply the keyword static, and we'll apply it to both variables and take a look what happens. So first of all, we have static int x. So what have we done here? Well, we haven't changed anything about where x is stored. It's still just stored at a static memory address. Nothing changed there. What has changed now is that x is now local to this module. So any functions that are in this file can access x. Other modules are unable to do so. So it's local to the module. So we have changed its scope, but not its storage. Inside the function, the int y declaration is now static int y, and the variable y now is stored in static memory, fixed memory location. This means that although the scope of y has not actually changed, it's still the rest of this function. Its lifetime will change because the value will survive exiting from this function and calling it again. So the value would survive between calls to the function. So here, static has changed the scope of one variable and not affected its storage. And in the other case, it has not affected the scope, but changed the way it's stored. And I think that's confusing. It would have been a lot better if it had an additional alternative keyword, maybe local, which would enable you to make a variable local to the module and would have no effect on its storage. Because where we've got static int x here, we haven't changed its storage, it's just local to this module. And we can apply this to functions as well. We could have made fun static, in which case that function would not be global anymore. There is a third meaning of the keyword static, and this is only applicable in C++. If we have a class, and we have a member variable, in this case we have class C, and we have a member variable which is an int called Z for people on the other side of the Atlantic. If we declare it static, as I have here, it doesn't change anything much about the variable in terms of its storage. What it does change is the accessibility. This variable actually is shared between every instance of the class C. So any objects created from class C, the member variable Z is the same one in every case. This enables all objects to share data. So three completely different meanings for one keyword. I think it's confusing, and I think many other developers do. But hopefully I've given you some clarity, and I hope that is helpful for you. So that's all for today. I'll be back soon with another embedded software topic. If there's something particularly you'd like to hear about, let me know. Otherwise, I will see you soon. Bye for now.